coefficient of x cubed in the expansion of 3 plus 2ax to the power of 5 is 6 times the coefficient of x squared in the expansion of 2 plus ax to the power of 6. Okay, now bear in mind, it's not necessary to expand both of these binomials completely. We only require, from the first expansion, we only require the coefficient of x cubed, and from the second expansion, we only require the coefficient of x squared. So it's not necessary to expand both completely. So with the first binomial, we will have 5 choose 0, 3 to the power of 5, plus 5 choose 1, 3 to the power of 4, times 2ax, and we'll just put that to the power of 1, plus 5 choose 2, 3 to the power of 3, times 2ax squared, plus 5 choose 3, 3 squared, times 2ax to the power of 3, plus 5 choose 4, 3 to the power of 1, times 2ax to the power of 4, plus 5 choose 5, times 2ax to the power of 5. Now, from this expansion, we only need the coefficient of x cubed out of the expansion of this binomial. So we're not going to bother trying to determine and evaluate any of the terms that do not contain an x cubed. So we are only purely looking at this term over here. That's all we're interested in, because this is the only term that has an x cubed component. The first term has no x, the second term has a single power of x, the third term an x squared, the fourth term x to the 4, and the last term x to the 5. So we're only interested in this term over here, the fourth term. Okay, the second part of the question, from the expansion of this binomial, we only need the coefficient of x squared. So 2 plus ax to the power of 6 equals 6 choose 0 times 2 to the 6 plus 6 choose 1 times 2 to the 5 times ax to the 1 plus 6 choose 2, 2 to the 4 times ax squared plus 6 choose 3 times 2 cubed times ax cubed plus 6 choose 4 times 2 squared times ax to the 4 plus 6 choose 5, 2 to the 1 times ax to the 5 plus 6 choose 6 ax to the power of 6. Again, we are only looking for the coefficient of x squared. So we are only concerned with this term over here. Every other term contains no power of x, or a power of x that is less than 2 or greater than 2. So we are only concerned with this term over here and that term from the first expansion. Okay, now they tell us that the coefficient of x cubed in the first expansion, so the coefficient from this expansion is 6 times the coefficient of x squared in this expansion. So we now just need to evaluate these coefficients. So from the first expression, okay, 5 choose 3 equals 5 factorial over 3 factorial times 5 minus 3 factorial, which is also the same as 5 times 4 times 3 over 3 times 2 times 1, which is 10. You can also get this from Pascal's triangle if you prefer. Um, you'll get the same coefficient there. Okay, then we multiply that by 3 squared, which is 9, times 2 cubed is 8, a cubed is a cubed, x cubed. So we have 72a cubed, x cubed. So now the coefficient of x cubed is everything in front of that. So the coefficient of x cubed is 720 a cubed. Okay, and then likewise with the second expression, we have 6 choose 2, 2 to the power of 4, ax squared. 6 choose 2 equals 6 times 5 over 2 times 1, times 2 to the 4 is 16, a squared, x squared. 30 over 2 is 15 times 16 is 240, and then we have a squared, x squared. So now the coefficient of x squared is 240 a squared. Now they are telling us that the coefficient of x cubed, which is 720 a cubed, is 6 times the coefficient of x squared, which is 240 a squared. So in other words, 720 a cubed equals 6 times 240 a squared. So 720 a cubed equals 1440 a squared. We can divide both sides by a squared, which will give us 720a equals 1440, and therefore a equals 1440 over 7. So a equals 2. Okay, question 2. Find the exact solution of the equation pi by 6 plus arctan 4x equals minus arccos root 3 over 2. Okay, they want an exact solution here, so we are not going to be leaving answers in terms of decimal. Okay, so pi by 6 plus tan to the minus 1 4x, or arctan 4x, equals minus cos to the minus 1, or minus arccos root 3 over 2. And we can evaluate this expression arccos root 3 over 2 in terms of degrees. This would evaluate to 30 degrees, but we are dealing with radians. So 30 degrees in terms of radians is pi by 6, and we've got that minus sign over there. And then we have pi by 6 on the left plus arctan 4x. We can now get an expression for arctan 4x. We can take this pi by 6 over to the right. So we'll have minus pi by 6 minus pi by 6 is minus 2 pi by 6, which is minus pi by 3. Now to get 4x, to isolate 4x, we're going to tan both sides of the expression. On the left, we now just have 4x, and on the right, tan minus pi by 3. Now, in terms of degrees, pi by 3 is 60 degrees. Tan minus 60 is minus tan 60. Right? And tan 60 is root 3. So tan pi by 3 will be root 3. And then we can just divide both sides by 4. And that is the solution. They want the exact solution, so they do not want this as a decimal. The exact solution is minus root 3 over 4. The equation of a curve is such that dy dx equals a half x plus 72 divided by x to the power of 4. The curve passes through the point P28. We are required to find the equation of the normal to the curve at P. Okay, now a normal is perpendicular to a tangent. A normal and a tangent are perpendicular lines. That means that the gradient of a normal times the gradient of a tangent is going to be -1. And we need this information in order to determine the equation of a normal. What we need to determine the equation of a normal, which is a straight line, we need the gradient, and we need not necessarily the y-intercept, but we do need a point. So you need the gradient and one point that lies on the line. So first things first, to find the gradient of the normal, we are first going to need to determine the gradient of the tangent to the curve at that point P. To get the gradient of the tangent, we look at what's been given to us here. dy dx, this expression over here, dy dx represents the gradient of a tangent to a curve. Now, this represents the gradient of any tangent to the curve. To find the exact value of a gradient of a tangent to a curve, you need to know what the point of contact is, and they've told us that the point of contact is P28. So the first thing we're going to do is determine the gradient of the tangent. So that will be when x equals 2, because that's the point of contact there, 28. So we will have a half times 2 plus 72 over 2 to the 4. It gives us 1 plus 72 over 2 to the 4 is 16, and that equals 11 over 2. Right, so this represents the gradient of the tangent to the curve at the point P28. Now the gradient of the normal will be the reciprocal value of the gradient of the tangent, but with opposite sign. So because the tangent has a positive gradient, the normal will have a negative gradient, and then it's the reciprocal of 11 over 2, which is 2 over 11. So we've got m now, we've got the gradient of the normal. We now need the point, and that point is the point of contact. So the point is P28, and now we can use y minus y1 equals m times x minus x1 to determine the equation of the normal. You can also use y equals mx plus c. There's nothing wrong with using that. It just requires an extra substitution. So y minus 8 equals minus 2 over 11 times x minus 2. So y minus 8 equals minus 2 over 11x plus 4 over 11. Y equals minus 2 over 11x plus 92 over 11. It's a bit of a messy way to write the equation of the normal, so we can just multiply everything through by 11. So 11y equals minus 2x plus 92, and this represents the equation of the normal to the curve at the point P28. And next we're required to find the equation of the curve. Now we were given an expression dy dx equals a half x plus 72 over x to the 4. This is the gradient function, the derivative function. So to find the equation of the curve, we need to integrate this expression. So dy dx equals x over 2 plus 72 over x to the 4. Now we're going to integrate this with respect to x. So we'll have y equals, half is a constant, and then the integral of x will be x squared divided by 2 plus this expression is 72x to the minus 4. So we have the constant term which you can pull out. X to the minus 4, when we integrate that we add 1, so it will be x to the minus 3, and then we divide by negative 3 plus the constant of integration. So y equals quarter x squared minus 24 over x cubed plus c. So this represents the equation of the curve. Now to find the value of c, we need to substitute the point 28 because the point 28 lies on the curve. So substituting 8 for y, 8 equals quarter and 2 for x. Quarter times 2 squared minus 24 over 2 cubed plus c. 8 equals a quarter times 4 is 1. 24 divided by 2 cubed is 24 divided by 8, which is 3. So 1 minus 3 plus c. 8 equals minus 2 plus c. c equals 10. So the equation of the curve is given by y equals a quarter x squared minus 24 over x cubed plus 10. The diagram shows the shape of a coin. The three arcs AB, BC, and CA are parts of circles with centers CA and B respectively. ABC is an equilateral triangle with sides of length 2 centimeters. We are required to find the perimeter of the coin. Okay, well, first thing we should do, let's just, because they've told us that ABC is an equilateral triangle, let's just draw in that triangle. And it has side lengths of 2 centimeters. So each of these sides, AC, CB, and AB, are 2 centimeters each. The perimeter of the coin is that arc length over there, AC, arc length BC, plus arc length AB, right? That's the perimeter of that coin. So to find arc length, remember that arc length equals the radius times the arc angle theta. Now for this particular arc, if we look at this arc AC, it is formed from that sector ABC, right? And the angle theta that we're referring to is this angle over here, right? Angle ABC. So to find the arc length AC, the radius of that sector is AB or BC, they 2 centimeters. So radius is 2, and theta is the interior angle of equilateral triangle ABC, which for an equilateral triangle, the interior angles are 60 degrees in terms of radians, pi by 3. So theta will be pi by 3. So the arc length AB, so arc length AC is 2 pi by 3. Now, when we do something similar to arc length AB, then we have this sector over here. The radius for that will be 2 centimeters again, and the angle is this angle here, theta. These are all theta, they're all 60 degrees, they're all pi by 3. So AB is going to have the same arc length as AC. So the arc length of AB will also be 2 pi by 3, and similarly, the same thing for BC. There's no need to go and do all this working out again because we're dealing with an equilateral triangle. So the perimeter of the coin will be 2 pi by 3 plus 2 pi by 3 plus 2 pi by 3, which is 6 pi by 3, which is 2 pi. So the perimeter of the coin is 2 pi centimeters. Next, we're required to find the area of the face ABC of the coin, giving the answer in terms of pi and root 3. Okay, so let's draw that equilateral triangle in again. Now the area of ABC is obviously going to be the area of that surface, right? Now what that surface comprises is this segment, that segment, that segment, and the equilateral triangle. Now we don't have a formula for the area of a segment, but we do have sectors. We know the area of a sector. The area of a sector is a half r squared theta. And now we've got a sector. This is one sector here. We have another sector there, and yet another sector. Yeah. Okay, we've got three sectors. Now, if you take the area of each of those sectors, it, you will get the area of each of the segments that were highlighted, but you're also going to be including the area of the equilateral triangle 3 times. And we only need, we obviously that is not, and obviously the area of the coin includes only one instance of the equilateral triangle. So this is what we're going to do. We're going to determine the area of each of these sectors as we normally would, as if it was just a problem on its own. And then we are going to subtract twice the area of the equilateral triangle, leaving us with just the area of one instance of the equilateral triangle. So we're going to start with the area of sector, let's call it sector 1. Let's just take all these markings off. So we'll start with this sector over here. The area will be a half, the radius is 2, so it's a half 2 squared, and theta is that angle, sorry, well, it doesn't make a difference, it's an equilateral triangle. That theta is pi by 3. So half times 4 will be 2 times pi by 3 is 2 pi by 3. Now each of these areas, because we're dealing with an equilateral triangle, if we find the area of that sector, the purple sector, it will also be 2 pi by 3, as will the area be of the yellow sector. So we have the area of all sectors will be 3 times 2 pi by 3, which is 2 pi. Now the area, the collective area of these sectors includes that segment, and that segment, but 3 instances of the equilateral triangle, because equilateral triangle was inherent in the sector of each sector that we had evaluated. So the area of the equilateral triangle, a half base times height, so it's a half. Now we don't have a perpendicular height. We're going to have to draw that perpendicular height in. So we're going to draw that perpendicular height in, call that h. This angle is, each of these angles are pi by 3, and AC or AB, whichever right angle triangle we're going to work in, ABAC has a length of 2. So let's just call that point there, the bottom of that height, D. So if we wanted to find the length of H or AD, we have an angle pi by 3 and we have a side 2. So H divided by 2, H relative to pi by 3 is the opposite side and 2 is the hypotenuse, so the ratio is sine. So that will be sine pi by 3. So H equals 2 sine pi by 3. So the area of the equilateral triangle is half base times height. The base of, now we don't have to look at triangle ACD, because if we look at equilateral triangle ABC, the base is CB and the height is HAD. We've just determined the height H, and BC is the side of the equilateral triangle, which is 2. So the area of the equilateral triangle is half CB times H, which is half CB is 2 and H is 2 sine pi by 3. So the area of the equilateral triangle is 2 sine pi by 3, and sine pi by 3 in degrees, that will be 60 degrees. Sine 60 is root 3 over 2. So the area of the equilateral triangle is root 3. So we have the area of all three sectors, which is 2 pi centimeter squared. We've got the area of the right of the equilateral triangle, which is root 3. Now, to find the area of the coin, we need to take the area of all three sectors, which is 2 pi, but we need to subtract two instances of the area of the equilateral triangle, because we inherent in each area of each sector was the area of the equilateral triangle. So we need to remove two instances of that equilateral triangle. So we're going to subtract 2 root 3, and this is the area of the coin. The first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta, respectively, with theta as an acute angle in radians. We're required to find the value of theta. Okay, so we have a geometric sequence. The first term is sine theta. The second term is cos theta. And the third term is 2 minus sine theta. So the first term of GS is A, the second term is AR, and the third term is AR squared. So using the first two terms, cos theta, the second term, equals AR. A equals sine theta because that's the first term. So R equals cos theta over sine theta. If you prefer, you can write that as cot theta. It may not be necessary to express it as cot theta. So R equals cos theta over sine theta. Now the third term is 2 minus sine theta, and that equals AR squared. So 2 minus sine theta equals A, which is sine theta, times R squared, which is cos theta over sine theta. So 2 minus sine theta equals sine theta times cos squared theta over sine squared theta. That sine will cancel with one of those. So 2 minus sine theta equals cos squared theta over sine theta. I'm now going to multiply every term by sine theta to get rid of that denominator. So we'll have 2 sine theta minus sine squared theta equals cos squared theta. Now it may seem instinctive to take, or rather to write sine squared in terms of cos squared, or cos squared in terms of sine squared, through the square identity. But an even better way is to take, you can do that if you wanted everything in terms of sine. Well, you would express cos squared theta in terms of sine squared theta, because you have sine in all the terms on the left hand side. But probably a better way and much quicker way of solving this equation is to take the minus sine squared over to the right, because when you do that, you'll have sine squared plus cos squared, which you know is 1. So 2 sine theta equals sine squared theta plus cos squared theta. So 2 sine theta equals, this expression is now 1. So sine theta equals a half. Therefore, theta equals, now just be careful here, theta is in radians. So shift sine a half, if you're working in degrees, is 30 degrees. In radians, 30 degrees is pi by 6. And next, using this value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over root c minus 1, where b and c are integers to be found. Okay, so theta is pi by 6. Recall the first term sine theta, the second term cos theta, the third term 2 minus sine theta. So using this value of theta, which is pi by 6, then the first term is sine pi by 6. Sine pi by 6, pi by 6 is 30 degrees, equivalent to 30 degrees, so sine 30 is a half. That's your first term, so a equals a half. Term 2 is cos theta, cos pi by 6. In terms of degrees, that's cos 30, which is root 3 over 2. So AR equals root 3 over 2. AR is term 2. And term 3 is 2 minus sine pi by 6. 2 minus a half, which is 1 1/2 or 3 over 2. So AR squared equals 3 over 2. So AR equals root 3 over 2. That's from that expression there. A is a half, so you'll have a half R equals root 3 over 2. And therefore R equals root 3. Now we're required to find the first 10 terms, sorry, the sum of the first 10 terms of that expression. So we want the sum to 10 terms. Then are there two expressions for the sum to n terms for a geometric sequence? The first one is a times r to the n minus 1 over r minus 1, where r is greater than 1, and it equals a times 1 minus r to the n over 1 minus r, where r is less than 1. Now r is root 3, which is greater than 1. It's approximately 1.73. So we're going to be using the first expression. So the sum to 10 terms will be a, which is a half, times r to the n, so root 3 to the n, root 3 to the power of 10, minus 1 over r minus 1, root 3 minus 1. Okay, so that equals a half times root 3 is 3 to the half, and then that's to the power of 10 minus 1 divided by root 3 minus 1. So that's going to be a half. You can use your calculator to evaluate the numerator. Half times 3 to the 5 minus 1 over root 3 minus 1. That's going to be a half times 3 to the 5 is 243 minus 1 is 242 over root 3 minus 1, and that equals 121 over root 3 minus 1, which is in this form over here. So B is clearly 121 and C equals 3. Question 6. The equation of a curve is given by y equals x squared minus 8x plus 5. Find the coordinates of the minimum point of the curve. Okay. Firstly, this is a quadratic function, right? And this particular quadratic function has a value of a, which is 1, which is clearly greater than 0, which means that the function shapes up, which means that we have a minimum turning point, right? So that's what that is referring to, the minimum turning point. The minimum point of the curve is referring to the turning point of the quadratic function. We are required to find the coordinates of that point. Probably the best way to go about doing this, well, actually, I wouldn't say the best way. There's two different ways. You can either complete the square and get this quadratic function into turning point form, or you can simply find the axis of symmetry, x equals minus b over 2a. Might be simpler to do that, and then substitute that x value into the function to get the y value. That gives you the turning point. But we'll do both. We'll complete the square as well. So finding the axis of symmetry, x equals minus b, b is minus 8, so it's minus 8 over 2 times 1. 8 over 2 is 4. So this is your axis of symmetry. And then if we just call this f of x, it really doesn't matter. F of 4 equals 4 squared minus 8 times 4 plus 5. 16 minus 32 plus 5. Minus 16 plus 5 is minus 11. So your turning point is 4 minus 11. Now, to complete the square, get this into turning point form. From standard form, we're going to complete the square. So we're going to add a bracket square. Whenever completing the square, you always need to ensure that the coefficient of x squared, or the squared term, is always 1, which it is here, so we don't have to do anything there. Then we add a bracket squared and subtract a bracket squared. Inside the bracket, is half the coefficient of x, so half of minus 8 is minus 4. Then the first three terms form a perfect square trinomial, x minus 4 all squared, and 5 minus 16 will be minus 11. And this is the function. So clearly we can see that the turning point, this is p has a value of 4, and q is minus 11. Recall that the turning point form is y equals a times x minus p all squared plus q. So p equals 4, excuse me, and q equals minus 11. So there is your turning point. So you can choose either of those methods to find the coordinates of the turning point of the quadratic function. The curve is stretched by a factor of 2 parallel to the y-axis and then translated by the vector 4, 1. So in other words, once we've stretched the function by a factor of 2 parallel to the y-axis, we're then going to move the resulting function 4 units to the right and 1 unit up. So we're going to perform a translation. Find the coordinates of the minimum point of the transformed curve. Now the curve is y equals x squared minus 8x plus 5, or in turning point form, x minus 4 all squared minus 11. Now it's probably better to use the turning point form because we got the turning point directly from that, and we're looking for the coordinates of the transformed turning point. So y equals x minus 4 all squared minus 11. Let's just call this function f of x. It's just nicer to refer to it as f of x so that we can refer to the transformed shapes in a similar fashion. So we're first going to stretch f of x by a factor of 2 parallel to the y-axis. This is a vertical stretch. So the new function, so the stretched function, we're going to call g of x, and g of x will be twice f of x. So it's going to be 2 times x minus 4 all squared minus 11. Now we're going to bring this 2 into the square brackets. 2 times x minus 4 all squared minus 22. So that's g of x. Now g of x is now translated using the vector 4, 1. So the new function, the transformed function of g of x, we're going to call h of x. And we're now going to shift 4 units to the right. So it will be 2 times x minus 8 all squared and 1 unit up. So minus 22 plus 1 will be minus 21. So the turning point of h of x will be 8 minus 21. Just recall that the turning point form of a quadratic is a times x minus p all squared plus q. Now the shift, we shift to the right when p is greater than 0, and when p is less than 0, we shift to the left. Now this is a positive shift, so this shift, that's p equals 4, the shift, and q equals 1. So when we shift 4 units to the right, this x minus 4, when we are shifting to the right, we are subtracting, so that'll be x minus 8. So that's where that x minus 8 comes from, and the shift of q is positive 1. So this value over here, q equals minus 2 for g of x, we add 1 to that to get the value of q for h of x. Find the equation of the transformed curve. Give the answer in the form y equals ax squared plus bx plus c, where a, b, and c are integers to be found. So h of x, that's what we called the function, was 2 times x minus 8 all squared minus 21. So to get this in standard form, we have to multiply out. So it's going to be 2 times x squared minus 16x plus 64 minus 21. That's 2x squared minus 32x plus 128 minus 21. So h of x equals 2x squared minus 32x plus 107. So a is therefore 2, b is minus 32, and c is 107. Question 7. Verify the identity 2x minus 1 times 4x squared plus 2x minus 1 equals 8x cubed minus 4x plus 1. Okay, so all we're required to do here is really just to multiply each term with the first bracket with each term inside the second brackets. So we'll have 8x cubed and then 4x squared minus 2x, and then do likewise with the last term with the first set of brackets. So we'll have minus 4x squared minus 2x and then plus 1. So that equals 8x cubed. 4x squared minus 4x squared is 0. Minus 2x is minus 4x plus 1, which is what we're required to show. Okay, next we're required to prove the identity tan squared theta plus 1 over tan squared theta minus 1 equals 1 over 1 minus 2 cos squared theta. Now, general rule of thumb when proving trigonometric identities is to start with the more complex side of the equation. In this case, that looks to be the left-hand side. So tan squared theta plus 1 over tan squared theta minus 1 equals, now we're going to be changing tan into the quotient identity sine over cos, because we've only got a cos, we've got the trig ratio of cos on the right hand side. So everything on the left hand side will have to ultimately transform into cos theta. So we have sine squared theta over cos squared theta plus 1 divided by sine squared theta over cos squared theta minus 1. So getting a denominator for the fractions in the numerator, we'll have sine squared theta plus cos squared theta over cos squared theta, and then likewise in the denominator we'll have sine squared theta minus cos squared theta over cos squared theta. We can now tip in times, so sine squared theta plus cos squared theta over cos squared theta times cos squared theta over sine squared theta minus cos squared theta. Cos squared will cancel with cos squared. Sine squared plus cos squared is 1, so we'll have 1 over sine squared theta minus cos squared theta. Now the right hand side contains only cos theta, so we're going to change the sine squared into cos squared. Recall that the square identity is sine squared plus cos squared equals 1. So we'll have 1 over sine squared will be 1 minus cos squared, 1 minus cos squared minus cos squared theta, and that equals 1 over 1 minus cos squared is minus 2 cos squared theta, which equals the right hand side. If there's anything you're unsure of in this video, there are detailed videos covering each concept in this video down in the description box below, so make sure that you check that out. Also, if you like this video, then please give it a thumbs up and subscribe to the channel. It really just helps the algorithm get my videos out there to reach a wide audience. And using the results of the previous two questions, solve the equation tan squared theta plus 1 divided by tan squared theta minus 1 equals 4 cos theta, for theta is an angle between 0 and 180 degrees. Okay, so tan squared theta plus 1 over tan squared theta minus 1 we just showed equals 1 over 1 minus 2 cos squared theta. So this expression here equals 1 over 1 minus 2 cos squared theta. So to solve the equation, we're going to be solving 1 over 1 minus 2 cos squared theta equals 4 cos theta. We're doing this, and the reason why you had to show and prove this identity in the previous question was because you're now solving a trigonometric equation, and you can only solve a trigonometric equation if you are dealing with a single trigonometric ratio. So we couldn't have solved it using tan and cos, right? Everything has to be expressed in terms of a single trigonometric ratio. That's why we had to prove identity in the first place. So now to solve this trigonometric equation here, we're going to multiply through by the denominator. So 1 equals 4 cos theta times 1 minus 2 cos squared theta. Multiplying in, 1 equals 4 cos theta minus 8 cos cubed theta, which if we write it in with all terms on one side and the other side equal to 0, we're going to get 8 cos cubed theta minus 4 cos theta plus 1. Now, they asked you to also use part A. Now recall that part A required us to show that 2x minus 1 times 4x squared plus 2x minus 1 equals 8x cubed minus 4x plus 1. Now, looking at this expression here and this expression here, you can clearly see they're very similar. X equals cos theta. When you compare the two equations, x is clearly cos theta. Therefore, 8 cos cubed theta minus 4 cos theta plus 1 we can express as 2 cos theta minus 1 times 4 cos squared theta plus 2 cos theta minus 1 equals 0. We've just replaced from part A of this question, we showed that the product of two polynomials, 2x minus 1 times 4x squared plus 2x minus 1 equals 8x cubed minus 4x plus 1. Now in the second part, we've got a trigonometric equation that is all the same. It's the same as that expression, other than the fact that we've replaced x with cos theta. And that's all we're doing now, solving for theta. So either this bracket is 0, so 2 cos theta minus 1 equals 0, cos theta equals half, so theta will be 60 degrees. We are working in the interval 0 to 180, so cos is positive in the first quadrant and the fourth quadrant, so it will be 60 degrees or 360 minus 60, 300 degrees, but we're working in the interval 0 to 180. We're only working in these two quadrants here. So for this particular equation, theta is 60 degrees for 2 cos theta minus 1 equal to 0. And then this bracket can also be 0. So 4 cos squared theta plus 2 cos theta minus 1 equals 0. We're going to have to use the quadratic formula here if there is a solution. So the first thing we need to do is check that there is a solution. So we're just going to check delta. So delta is going to be 2 squared minus 4 times 4 times minus 1. That is going to work. So we are going to use the quadratic formula. So cos theta is 0.309, or cos theta equals minus 0.809. Now, we're only going to use the positive, the acute angle here, because cos is positive, like as I said, in the first and the fourth quadrant, and we're not working in the fourth quadrant, so we're just going to take the first quadrant solution, 0.309 shift cos. Make sure that you're working in degrees. So theta is 72 degrees, or now theta is negative, so the only quadrant we're going to work in, cos theta is negative in the second and the third, but we're only going to be looking in the second quadrant because that is our domain. So shift cos 0.809, take 180 off, take that off 180, theta is 143.99, so we're going to approximate that as 144 degrees. So theta equals 60, 72, or 144 degrees. Functions f and g are defined by f of x equals x plus a all squared minus a for x less than or equal to minus a, and g of x equals 2x minus 1 for x is an element of real numbers, and a is a positive constant. Find an expression for the inverse of f of x. So f of x equals x plus a all squared minus a. To find the inverse function, we just replace x with y. So x equals y plus a all squared minus a. And now we're solving for y. So x plus a equals y plus a all squared. Y plus a therefore equals plus or minus the root of x plus a. Y equals minus a plus or minus root x plus a. This now represents the inverse of f of x, which is now going to be written as f to the minus 1 of x equals minus a plus minus root x plus a. State the domain of the inverse function of f. So the inverse function of f equals minus a plus minus root x plus a, and we need to now state the domain. Now, the domain of, we have a square root bracket here, so we have a restriction. That restriction is that the contents of that square root bracket can never be negative, because the square root of a negative number is always a non-real number. So our restriction here is that x plus a must be greater than or equal to 0. In other words, x is greater than or equal to minus a. So this is the domain for the inverse function. State the range of the inverse function of f is the range of the inverse function is the domain of the original function f of x. So this is your domain over here. So the range of the inverse function will be y is less than or equal to minus a. Okay, given that a equals 7 over 2, solve the equation g of f of x equals 0. So g of f of x equals g of x plus a all squared minus a, and they told us that a equals 7 over 2. So that'll be g of x plus 7 over 2 all squared minus 7 over 2. Now, g of that expression, wherever we see an x in g of x, we're going to substitute it with that expression there. So we're going to have 2 times x plus 7 over 2 all squared minus 7 over 2 and then minus 1. Now we want to solve the equation g of f of x equals to 0. So we're just going to equate that to 0 and solve. So 2 times x plus 7 over 2 all squared minus 7 over 2 equals 1. We're just taking this across to the right. You can multiply out these brackets, bring the 2 into the resulting expression, subtract 1, get a standard quadratic equation, factorize and solve for x, but that might be too time consuming and tedious. So the best approach is to perform reverse Bolognese and just isolate all the terms containing x. Now we're going to bring 2 into the square bracket. So 2 times x plus 7 over 2 squared minus 2 times 7 over 2 will be minus 7. That equals 1. 2 times x plus 7 over 2 all squared equals 1 plus 7, which is 8. x plus 7 over 2 all squared, divide both sides by 2, equals 4. Square root both sides now, so x plus 7 over 2 equals plus or minus 2. X equals minus 7 over 2 plus or minus 2. So x is minus 7 over 2 plus 2, or x equals minus 7 over 2 minus 2. Minus 7 over 2 plus 2 will be minus 7 plus 4. That's going to be minus 3 over 2. And minus 7 over 2 minus 2 is minus 7 minus 4. That'll be minus 11 over 2. Now recall that the domain for f of x was that x is less than or equal to minus a, and they said that a equals 7 over 2. So x must be less than or equal to minus 7 over 2. Now, minus 3 over 2 is larger than minus 7 over 2, so this solution will not be applicable. Minus 11 over 2 is smaller than minus 7 over 2, so that is your one and only solution to g of f of x equals 0. The diagram shows curves with equations y equals 2x to the half plus 13x to the minus a half, and y equals 3x to the minus a half plus 12. The curves intersect at points A and B. We are required to find the coordinates of A and B. Okay, so to find points of intersection, we simply equate the two functions to each other. So 2x to the half plus 13x to the minus a half equals 3x to the minus a half plus 12. You can use a substitution here if you like. It actually might be a little bit easier. If we let p equal x to the half, then we'll have 2p plus 13 divided by p equals 3 divided by p plus 12, and then multiply through by p. This just might be simpler than working with a fractional exponent. So we'll have 2p squared plus 13 equals 3 plus 12p. Obviously p cannot be 0. So 2p squared minus 12p plus 10 equals 0. Divide through by 2. P squared minus 6p plus 5 equals 0. P minus 1 times p minus 5 equals 0. P equals 1 or p equals 5. And we said that p was x to the half, so we'll have x to the half equals 1 or x to the half equals 5. Then we square both sides. So x equals 1 squared, which is 1, or x equals 5 squared, which is 25. Now that just represents the x coordinates of the points of intersection. So A is the point 1, y. We're going to determine what that y coordinate is in a bit. And B is 25, y, 2. Now to determine the y coordinates of these points A and B, we're just going to substitute the x values into either of the functions because they're points of intersection, which means that those points lie on both functions. So sub into this formula over here. So y equals 3. We're subbing in x equals 1 now. 1 to the minus a half plus 12. There'll be 3 plus 12, which is 15. So A is the point 115. And likewise B will be 3 times 25 to the minus a half plus 12. That's going to be 3 times 5 squared to the minus a half plus 12. That's 3 times 5 to the minus 1 plus 12. So that's 3 over 5 plus 12, which is 63 over 5. So B is the point 25, 63 over 5. Okay, the next question, hence find the area of the shaded region. So A is the point 115 and B is the point 25, 63. over 5. So to find the area of the shaded region, we're integrating. The boundaries of integration will be the vertical lines x equals 1 and x equals 25. So we're going to be integrating. So the area, the shaded region, will be the integral from x equals 1 to x equals 25. Excuse me. And the area will be the top curve minus the bottom curve. That's our expression here. I'm just going to write it as top minus bottom for now with respect to x. So let's just get an expression for the top minus the bottom curve. It will be 3x to the minus a half plus 12 minus 2x to the half plus 13x to the minus a half. So that'll be 3x to the minus a half minus 13x to the minus a half be minus 10x to the minus a half plus 12 minus 2x to the half. So this expression is what we're going to be integrating. So that equals, we're integrating, 10 is a constant, so it's going to be minus 10 times, integrating x to the minus half, we add 1 to minus a half gives us a half, so it's going to be x to the half divided by a half, and then this is evaluated between x equals 1 and x equals 25, plus 12 times, there is no x here, it's x to the power of 0, so we add 1 and we'll have an x divided by 1, and that's evaluated between x equals 1 and x equals 25, minus 2 times x to the half, we add 1, so we have x to the 3 over 2, and we divide it by 3 over 2, and that's evaluated between x equals 1 and x equals 25. So that's going to be minus 10 divided by half is the same as minus 10 times 2. So it's going to be minus 20 times. Then x to the half will be 25 to the half, which is 5 squared to the half minus 1 to the half plus 12 times 25 minus 1 minus 2. Now 2 divided by 3 over 2 is the same as 2 times 2 over 3, so that's going to be minus 4 thirds times 25 to the 3 over 2 is 5 squared to the 3 over 2 minus 1 to the 3 over 2. So that equals minus 20 times 5 squared to the half is 5 to the 1, so it's going to be 5 minus 1, which is 4, plus 12 times 25 minus 1 is 24, minus 4 thirds times, that's going to be 5 to the 3, which is 125 minus 1, that's 124, so that's minus 80 plus 288 minus 496 over 3. So the area of the shaded region is therefore 128 over 3 units squared. If you like, as a decimal, that is approximately 42.7 units squared. Okay, question 10. The equation of a curve y equals f of x is given by f of x equals 4x minus 3 to the power of 5 thirds minus 20 thirds x. We are required to find the x-coordinates of the stationary points of the curve and determine their nature. Now recall that for stationary points, the derivative function equals 0. So f prime x equals 0 at stationary points. So we're first going to find an expression for the derivative function, and then we're going to equate it to 0 and solve for x. So f prime x will be 5 thirds times 1 times 4x minus 3, and then we subtract 1 from 5 thirds, so 5 thirds minus 1 is 5 thirds minus 3 over 3, which is 2 thirds, And using the chain rule, we also multiply by the derivative of this expression 4x minus 3. So the derivative of 4x is just going to be 4 minus 1 times 20 thirds. Then x to the 1 minus 1 is x to the 0, which is just 1. So we just have 20 thirds. And this expression equals 0. So just clean that up. 5 thirds times 4 is 20 thirds times 4x minus 3 to the 2 thirds minus 20 over 3 equals 0. We can divide through by 20 thirds because that is a constant. So we'll have 4x minus 3 to the 2 thirds, taking this term across, equals 1. Now we're going to raise this to the third. So 4x minus 3 all squared will equal 1. The reason we've done this is because of the presence of this 2 in the numerator of that fraction. It's the cube root. 4x minus 3 to the 2 thirds is the cube root of 4x minus 3 squared. Now this squared over here, because of the presence of that squared, when you square it to quadratic, you're going to get two solutions. So just be very, very careful in a situation like this, as in this example over here. So when you square root this now, we're going to get plus or minus 1. So 4x minus 3 equals plus or minus 1. If we just take the positive solution, we're only going to get 1 of the terms. So 4x equals 3 plus or minus 1. 4x equals 3 plus 1, or 4x equals 3 minus 1. So 4x equals 4, x equals 1, or 4x equals 2, x equals a half. So these are the x coordinates of the stationary points of the curve. Now to determine the nature of these stationary points, we're going to use the double derivative, second derivative. So the function is f of x equals 4x minus 3 to the 5 thirds minus 20 thirds x. The first derivative is 20 thirds times 4x minus 3 to the 2 thirds minus 20 thirds. The second derivative will be 20 thirds times 2 thirds. So it'll be 40 over 9 times 4x minus 3. We're subtracting 1 off 2 thirds, so we'll have minus a third. We multiply by the derivative of 4x minus 3, so we multiply by 4 using the chain rule, and that's a constant term, so the derivative is 0. So this will equal 40 times 4 is 160 over 9 times 4x minus 3 to the minus a third. That is the second derivative. We now need to determine the nature of these turning points. So f prime of 1 will be 160 over 9 times 4 times 1 is 4 minus 3 is 1 to the minus a third is still 1. So that's 160 over 9, which is clearly greater than 0. So we're going to have a minimum turning point, a minimum stationary point at x equals 1, and f prime a half will be 160 over 9 times 4 times a half is 2, 2 minus 3 is minus 1, to the power of minus a third is going to be minus 1, so that's minus 160 over 9, which is clearly less than 0. So we have the maximum stationary point where x equals a half. Next, we are required to state the set of values for which the function f is increasing. Now, a function will increase when the first derivative is greater than 0. It will decrease when the first derivative is less than 0. So we're interested in when the function is increasing. Now, the function f prime x was 20 thirds times 4x minus 3 to the 2/3 minus 20 over 3. The function f of x will increase when the first derivative is greater than 0. So in other words, when that expression is greater than 0. To simplify this, we can divide through by 20/3 because it's a non-zero constant. So 4x minus 3 to the 2/3 minus 1 is greater than 0. Now, instead of solving this quadratic inequality, just recall we've already solved the equation equivalent of this expression over here, for which the values of x were x equals 1 or x equals a half. So these are essentially your critical values for this inequality, right? That's what the critical values represent. It's the intermediate step that represents the solution to the corresponding equation, equivalent equation. So your critical values are a half and 1. So we'll put those on the number line. And then we go plus, minus, plus. We have an open circle above each of these critical values, and because it's greater than 0, we're looking in the positive region. So the solution to this inequality will be x is less than a half or x is greater than 1. The coordinates of points A, B, and C are 6, 4, P7, and 14, 18 respectively, where P is a constant. The line AB is perpendicular to the line BC. Given that P is less than 10, we're required to find the value of P. Okay, it's always a good idea with coordinate or analytical geometry to draw a sketch, right? A sketch helps a hell of a lot in not only conceptualizing and visualizing the problem, but knowing where to start the problem. So we are going to draw a rough sketch. A is the point 6, 4. We'll leave B alone for now because we don't know what P is. C is 14, 18. So we'll be somewhere there. So this is A, and that is C, right? Because AB has to be perpendicular to BC. So AB, BC, we're going to have something like this. Right? And it's not going to be there because B has to be, sorry, P is less than 10. So let's say that B is there then. Right? And that does look like it could be perpendicular. What do we know about perpendicular lines? Perpendicular lines, the product of the gradients of those lines is -1. So in other words, the gradient of AB times the gradient of BC is -1. So let's just determine the gradient of AB and BC as a start. A is 6, 4, B is P7, and C is 14, 18. So the gradient of BC, doesn't matter where we start, will be 18 minus 7 over 14 minus P. That's 11 over 14 minus P. The gradient of AB will be 7 minus 4 over P minus 6, which is 3 over P minus 6. Now the gradient of BC times the gradient of AB is -1 because AB is perpendicular to BC. So 11 over 14 minus P times 3 over P minus 6 equals -1. 33 equals minus times, and we're just multiplying these two denominators and just moving them, multiplying both sides by the product of those denominators to get rid of the denominator. Now we can multiply out, so 33 equals minus times 14p minus 84 minus p squared plus 6p. 33 equals minus 14p plus 84 plus p squared minus 6p. Getting all the terms over to the one side. P squared minus 20p, 84 minus 33 is 51 and equals 0. So p, the factors of 51 that give you a sum of 20 is 17 and 3, or 3 and 17. So p equals 3, or p equals 17. They said that p is less than 10, so this will be not applicable. So p equals 3. Circle passes through the points A, B, and C, and we are required to find the equation of the circle. Now, since we are told that AB is perpendicular to BC, we know that angle B is, or rather angle ABC is 90 degrees. The fact that we've got a circle passing through the points A, B, and C implies that AC has to be a diameter, because the angle subtended by a diameter at the circumference of a circle is a right angle. It's always 90 degrees. So the fact that angle ABC is 90 degrees, when we join AC, it implies that AC is a diameter. So A is the point 64, C is the point 1418. AC is a diameter, which means half the diameter is going to be the radius. Right? So the equation of a circle is x minus a all squared plus y minus b all squared equals r squared. We'll worry about the center in a bit. It really doesn't matter how we start. We're going to have to use line segment AC or diameter AC to get the midpoint. We're just going to use the midpoint. To get the center of the circle, we're just going to find the midpoint of AC. So, and to find the radius of the circle, we're just going to find the length of AC and half it. So it doesn't matter where we start. Let's just start with AC. Choose the distance formula. So AC will be 14 minus 6 all squared plus 18 minus 4 all squared. Remember that the distance formula is given by D equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So AC is the square root of 14 minus 6 is 8, 8 squared is 64, 18 minus 4 is 14 squared is 196. So AC is the square root of 260. So AC in simplest form, third form, is 2 root 65. Therefore, the radius is half of that. So half of 2 root 65 is just going to be root 65. So we've got R. We now just need to find the midpoint of AC, which is the center of the circle. So the midpoint of AC is x2 plus x1 over 2, y2 plus y1 over 2. So it's going to be 14 plus 6 over 2, 18 plus 4 over 2. That's going to be 20 over 2 is 10, and 22 over 2 is 11. So the midpoint, you can call that center M. So M, the center of the circle, is the point 10, 11. Okay, so the equation of the circle is therefore x minus 10 all squared plus y minus 11 all squared equals root 65 squared. So x minus 10 squared plus y minus 11 squared equals 65. You can leave it in that form. Finally, find the equation of the tangent to the circle at C, giving the answer in the form dx plus ey plus f equals 0, where d, e, and f are integers. Let's just draw in a tangent at C. Now, we know that a tangent is perpendicular to a radius or diameter of a circle. So we know that AC is a diameter. So if we were required to find the equation of the tangent at C to the circle, then the gradient of AC times the gradient of the tangent at C equals -1, because they are perpendicular lines. So the gradient of AC equals, let's just write down the points here. A is 6, 4, C is 14, 18. So the gradient of AC will be 18 minus 4 over 14 minus 6. So that's 14 over 8, which is dividing by 2, 7 over 4. Therefore, the gradient of the tangent will be the reciprocal with opposite sides. So it'll be minus 4 over 7. Now C is the point 14, 8. So we've got the gradient and the point that lies on the line. So we can determine the equation of the tangent. So the equation of the tangent, y minus y1 equals m times x minus x1. So y minus 18 equals minus 4 over 7 times x minus 14. Y equals minus 4 over 7x plus 8 plus 18. So the equation of the tangent will be minus 4 over 7x plus 26.